Ladies, this is Chapter 2, Roman numeral 9, and we are in the practice problems for section 2.6. So what I'd like for you to do is to pause the screencast and find the vertical and horizontal and slant asymptotes for example 3. So for your slant asymptotes, there are none because the degrees are even. Because the degrees are even, the horizontal asymptote is the ratio of the leading coefficients, which 4 divided by 1 is 4. And the vertical asymptotes, when you factor the denominator, no factors cancel, so our vertical asymptotes are x equal plus or minus 3. The next thing I'd like for you to do is pause the screencast and find the x and y intercepts of this rational function. So for your x-intercept, you should have the equation equal to 0. And then when you multiply both sides by x squared minus 9, you come up with 0 equals 4x squared. Divide both sides by 4, x squared equals 0. Take the square root, so x is equal to 0. Now remember, because this factor that gave us 0 occurred twice, 0 will have a multiplicity of 2, which means we will bounce. And then our y-intercept, plug in 0 here and here, 0 divided by negative 9 is 0. So we have an x-intercept of 0 and a y-intercept of 0. So let's graph the vertical asymptotes. We have vertical asymptotes at positive 3 and negative 3. We have a horizontal asymptote at 4. And then we would plot our x-intercept and y-intercept of 0. Okay, so notice that if we look at this function horizontally, we have 2 vertical asymptotes. So those divide our coordinate plane into 1, 2, 3 sections. So to determine where we will graph the function from negative infinity to negative 3, we'll use a table of values. And I'll go ahead and just select negative 6. You could use any x-coordinate to the left of negative 3. So when we plug in negative 6 squared is 36. And 36 times 4 is, and I'm using my calculator, so ladies, it's okay for you to do that too. 36 times 4 is 144. And then in the denominator, when you plug in negative 6, negative 6 squared is 36, and 36 minus 9 is 27. Let's go ahead and find an approximation for 144 divided by 27, and that is 5 1/3. So when I plot the point negative 6, 5 1/3, I am above the horizontal asymptote, so you know that this section will hug the asymptotes above y equals 4. For this middle section, you can choose a value between negative 3 and positive 3. Because 0 has already been used, I'll choose to use positive 1. 1 squared is 1. 1 times 4 is 4. Divided by 1 squared is 1. 1 minus 9 is negative 8. So when we plot our point, we would go right 1, down a half. That tells me that this section between the x-intercept and the vertical asymptote is below the x-axis. Now I'm going to refer back to when I found the x-intercept, and I said I would bounce at that point. So if I'm going to bounce, I know that this side would also remain below the x-axis. If you forget to check the bounce or are not sure what that looks like, you can always plug in an x value between negative 3 and 0. Finally, let's plug in an x value between 3 and positive infinity. And I'm going to use 6. So when using positive 6, we know that 6 squared is 36, times 4 is 144, divided by 6 squared is 36, and 36 minus 9 is 27, and that is 5 1/3. So for the final section, I'll go right 6, up 5 1/3, so I know that this section is also above that asymptote. For problem number 4, I want you to pause the screencast and find the vertical and horizontal and slant asymptotes, and go ahead and find the x and y intercepts, then come back. Let's see how you did finding your information. For the vertical asymptote, I cannot factor x squared plus 1. It's a sum of perfect squares. So to find where the denominator equals 0, we set x squared plus 1 equal to 0. Subtract 1, and notice when we take the square root of both sides, we come up with plus or minus I. Well, I is an imaginary number, so we know that because this is a real coordinate plane, there are no vertical asymptotes. So because x was equal to positive or negative I, there are no vertical asymptotes. The horizontal asymptote is y equals 4 because our degrees were the same. There is no slant asymptote. Our x-intercepts, when we substitute 0 in the place of y, multiply both sides by x squared minus 1. This is our new equation. And when we solve for x, we have x equals 0. But remember, because x was squared, that tells us that 0 has a multiplicity of 2, therefore it will bounce. And then our y-intercept, 0 divided by 1 is 0. All right, so let's plot our values. Our x-intercept is 0. We don't have a vertical asymptote, and our horizontal asymptote is 4. Okay. Now you might be thinking, oh my goodness, there is no vertical asymptote for me to figure out where to graph to the left and the right of. So I would encourage you to find points to the left of the x-intercept and to the right of the x-intercept. Let's use -2. So let's make a table. When x is -2, -2 squared is 4. 4 times 4 is 16. Divided by -2 squared is 4. 4 plus 1 is 5. Well, 16 divided by 5, 5 will go into 16 3 times with 1 left over. So we know we have a point at left 2, up 3, and 1/5. Now, I've been graphing this problem, I've graphed it over and over for years. I know what the graph looks like, but you might not yet know what it looks like. So if you don't, that's fine. Let's pick another point to help you. Let's use -6 this time. -6 squared is 36, and 36 times 4 is 144, divided by -6 squared is 36 plus 1 is 37. So 144 divided by 37 is approximately 3.9. Well, you might be wondering, is that higher than 3 1/5 or lower than 3 1/5? 3 1/5 is approximately, or is 3.2. So you know 3.9 is slightly higher. Left 6, up 3.9. So this section of the graph, as we go closer, or as we move further and further to the left, we will move closer and closer to our horizontal asymptote. We already know that we will bounce here, so the right-hand side will bounce. Number 5 has a typo in it. I need you to make the coefficient of -x -2. That does not look like a 2 at all. So make this x squared minus 2x plus 1. Now please find your vertical and horizontal asymptotes. When we take x squared minus 2x plus 1 and factor, it factors into x minus 1 times x minus 1. Well, one of these factors in the numerator should also cancel with the factor in the denominator. That leaves us with the remaining factor of x minus 1. So there is no vertical asymptote because there's no factor in the denominator, and there is no horizontal asymptote because the degree of the denominator is 0. There's no factor in the denominator, so the degree is 0. The degree of the numerator is 1. So this is top-heavy. There is no horizontal asymptote. Well, it is top-heavy, and it's top-heavy by 1 degree, which means we do have a slant asymptote. Now, remember, to find the slant asymptote, we divide the denominator into the numerator. Well, this one's easy for you. When you divide 1 into x minus 1, you come up with a slant asymptote of x minus 1. So in this case, your graph is y equals x minus 1. Is there anything I've left out here? Did you think about the fact that there will be a hole at x minus 1? Because those two factors canceled, you will have a hole where x minus 1 equals 0. So you will have a hole at the x-coordinate of 1. If you have a hole, you will have not only an x-coordinate but a y. So the corresponding y-coordinate, we plug the hole back into here, and 1 minus 1 is 0. So we will have a hole at 1, 0. So let's put that there now, over 1 up 0. What about our x and y intercepts? Well, to find the x and the y intercepts, we use the simplified function. We already found our x-intercept. It happens to be where the hole is. The y-intercept is f of 0. So 0 minus 1 is negative 1. Since our equation that remains is x minus 1, you know that is linear. So your y-intercept is negative 1, and then you would travel up 1, right 1, up 1, right 1, and continue that. Down 1, left 1, down 1, left 1, down 1, left 1, and so on and so forth. So when we graph this remaining piece, make sure that you stop when you get to your hole and then start again on the opposite side. Do not draw the function through the hole. Ladies, thank you for your time. I hope this helps. Please take time to do the homework so you're ready to ask me questions in class tomorrow.